Okay, Assalamualaikum and a very good morning to all of you. Okay, can you see the slide? Can. Alright. Okay, wait. Okay. Okay. Okay, so now we have 83 students. Okay, so I think we can start. Okay, okay, so the slide is clear or not? Is it clear? Okay. Okay, Assalamualaikum and a very good morning to all of you. Okay, I am Madam Shazwani. Okay, so I will teach you for the second part for this subject. Okay, which is entitled Material Balance on Reactive Single Unit Process. Okay. Okay. So, how are you today? Mm, every one of you have arrived at your hometown. Hmm? Semua dah sampai kampung ke? Ke ada lagi kat Unimap? Tak balik lagi? Semua dah balik kampung dah? Okay, bagus. Okay, so, okay, good. Very good. Okay, so, hope you can focus our class today. Okay. Okay, so, first of all, I want to ask you a question. Okay, how many of you plans to get to aims to be a chemical technologist or chemical engineer? Alright, good, very good. Okay, so to become a good chemical engineer, okay, you need to master well, okay, this subject, okay, because this is the principle of chemical process, right? Okay, so for this topic, okay, okay, so for this topic, okay, you are expected must be able to identify the chemical reaction stoichiometric, okay, in terms of the limiting and excess reactants, okay, and then fractional conversion, the extent of reaction, yield, and selectivity. Okay, and the second outcomes, okay, you need to able to analyze the reactive process using molecular species, okay, balance, atomic species balance and extent of reaction, and the last one, you must be able to perform material balance, okay, calculation on reactive single unit process. Okay, basically this topic you need to master well the principle and also mathematics. Okay. Okay, so basically what is chemical reaction stoichiometry? Uh, okay, so stoichiometry is the theory of the proportion of the chemical species with one another. Okay, that's mean the theory of proportion. That's mean proportion in Malay we call as perbandingan or perkadaran of one chemicals to another chemical species. Okay, what is the example for chemical species? Hmm? Can you give the example of chemical species? Okay, chemical species we have, for example, hydrogen, nitrogen, N2, okay, and hydrochloric, HCl. Okay, that is the example for chemical species. Okay, okay, so stoichiometric equations. Okay, we have a statement of the relationship between number of molecules or moles of reactants and product that involved in the reaction. Okay, stoichiometric equation means that the equation of chemical reaction lah. Okay, so in this equation, for example, okay, we have reactants which is SO2 and also oxygen. Okay, this is the reactants, and we have also the products. Okay, the reaction will produce SO3. Okay, and this equation must be balanced. Okay, so a valid stoichiometric equation must be balanced. Okay, we have to make the equation is balanced. Okay, so for example, for this reaction, chemical equation, okay, we can say that every 2 molecules of SO2 reacts with one molecules of oxygen, okay, to produce 2 molecules of SO3. Okay. Okay, next is stoichiometric coefficient. Okay, stoichiometric coefficient is the number written in front of atoms, ion and molecules in a chemical reaction to balance the number of each element on both the reactant and product sides of the equation. Okay, that's mean, okay, coefficient means that, what is coefficient? Eh, sorry. What is coefficient? Hmm. Hmm? What is coefficient? Coefficient in Malay we call as perkali. Okay, the number written in front of atoms or molecules. Okay, for example, for this chemical equation, for SO2, what is the coefficient for SO2? Hmm? What is the coefficient
Wow.
stoichiometric SO2? The number in front of chemical species. So, 2. Okay, good. So, coefficient, stoichiometric coefficient for O2, oxygen, is 1. Okay. And how about the stoichiometric coefficient for SO3? Hmm? What is the answer?
2.
2. Okay, good. Okay, so you understand, right? What is stoichiometric efficient coefficient? Okay. Alright. So the stoichiometric equation must be balanced. Okay. For this equation, the equation is balanced or not? Is it balanced? The equation is balanced or not? Balanced, right? So how we know
Balance.
that? How we know that the equation is balanced? We calculate the element for each chemical species, right? For example, sulfur. Okay, the number of element for sulfur is on the right side and the left side. On the right side, we have 2 sulfur, right? And on the left side, in the product side, we have 2 sulfur, right? Is it true?
Yes.
Oxygen. We have how many oxygen on our right side? 2 times 2 equals to 4, right? And then plus 2 equals to 6, right? We have 6 oxygen on the right, and we have on the left side, how many oxygen we have? 2 times 3 equals to 6, right? So is it balanced? The sulfur and oxygen on the right side and the sulfur and oxygen on the left side. Is it balanced?
Balance.
So we can say that this stoichiometric equation is balanced. Okay. Okay. Next. Reactant is negative and the value of V for each product is positive. Okay, this one we will see on the next slide. Okay, just you need to bear in mind that the coefficient for reactant is negative and the value for product is positive. Okay. Okay, for example 1. Let's try to do this example. Okay, we have this chemical equation 2SO2 plus O2 equals to 2SO3. Okay, so what is the stoichiometric coefficient for SO3? Hmm. Anyone can answer the first
2.
question? SO3, yes.
2.
So the answer is 2, right? Why we say 2? Because this one, right? Coefficient, the number in front of the chemical species. Okay. And next question, what is the stoichiometric coefficient of SO2? We have 2, right? And the last one, what is the stoichiometric coefficient of O2? We have hmm? We have 1, right? The answer is 1. Stoichiometric coefficient of oxygen, O2. Okay. Yeah. Easy, right? Easy or not? Okay, so next let's redo the exercise 1. Okay, try to balance each of chemical equation. Okay, the first one we have Ki plus Br2 equals to Kbr plus I2, right? Okay, so try to balance the first chemical equation.
KI letak 2. KBR letak 2.
Okay, I2 and Kbr2,
KBR.
right? Alright, good. Right answer. Okay, for the second one, okay, for question 1, we have You write the answer in the message for question 1, 2 Ki and also 2 KBR, right? Okay, next question for question 2. We have N2O3 plus H2O equals to HNO2. What is the coefficient for each chemical species? Hmm? Is it any equation? Is it any coefficient at N2O3?
Satu.
Yes, 1. Okay. How about H2O? H2O. What is the
One
coefficient?
also.
1 also. Okay, good. And how about the HNO2?
Kalau nak balance, dua.
Okay, good. So 2 HNO2. Right. Very good. Okay, next question. Question 3. Al plus HN4NO3 equals to N2 plus H2O plus Al2O3. Okay, is there any coefficient for Al, aluminium? Try to balance the equation first. Ni susah sikit kan? You have any elements, chemical elements here. We have Al, aluminium. We have hydrogen. We have nitrogen. And also we have oxygen, right? We have 1, 2, 3, and 4. 4 chemicals element. With the number of chemical elements on the left side. Okay. Okay, for the sorry. Internet technical problem. Sorry. Okay. Okay, so for Al, alumina. Can you balance the equation? What is the coefficient for alumina on the right side? Okay, so we try to calculate first. Okay, alumina on the right side, how many? One,
One.
right? Okay, on the left side, we have 2, right?
Sekejap.
Okay.
Right side. Right side yang aluminium 2O3 tu ke? Tu
Oh,
right kan?
bukan. Al, alumina only. This,
Oh. Sepatutnya dua lah.
Kalau macam tu kita tengok 2 kan. Sini 2. And then sini kosong. And sini 1. So tak balance. Okay, how about the nitrogen? Hydrogen. Hydrogen we have on the right side 1. And on the left side we have 2. Right? And how about the nitrogen? On the left side we have 4 plus 1 equals to 5. Right? And on the right nitrogen. So how to balance the nitrogen? And for the oxygen, on the right side we have 3. Okay, and on the left side we have 1 plus 3 equals to 4. 4 and 3, right? So for oxygen also not balanced, left and right. So how to make the equation balance? Any idea? Okay, sorry. Can you see the cursor? Boleh nampak cursor bergerak tak kat sini?
Nampak.
Nampak. Okay, good. Okay, so macam mana nak balancekan equation ni? Okay, so okay, right. So kita tengok kat sini nitrogen kat sini ada 5 kan? Okay, on the left side, on the product side we have nitrogen 2. So to make the equation balance, sini 5, sini 2. So kita jadikan dia sebagai berapa? 2/5, 10 lah kan? Betul tak? Okay, so kita jadikan nitrogen sebelah kanan 10 dan sebelah kiri pun 10. Okay, untuk jadikan nitrogen sebelah kiri, sebelah kanan ni 10, kena darab dengan berapa? HN4NO3 ni. Kita kena darab dengan berapa untuk jadikan nitrogen sebelah sini jadi 10?
2.
Darab 2 kan. Okay, so koefisien kat sini adalah 2. Okay, untuk balancekan nitrogen sebelah kiri, darab dengan
5.
berapa koefisien untuk nitrogen? Kita nak jadikan dia 10. Darab dengan
5.
5 kan? So kat sini koefisien di sini adalah 5. Okay. Okay, and then okay, kita dah letak sini 5. Ya, hidrogen kat sini equals to berapa bilangan hidrogen sebelah kanan ni? Berapa bilangan hidrogen sebelah kanan? Kita dah letak sini 5 kan? Betul tak?
Doktor ada lukis apa-apa ke doktor?
Okay, macam mana nak lukis? Exercise. Kita tulis dekat chat ni lah. Okay, macam mana nak tulis? Okay. Okay, so sini. Okay. Okay, yang ni complicated sikit kan. Okay, so basically dia matematik lah. Okay. So nanti you akan dapat 10 L plus 6. Okay. So you will get 15 plus 3H2O. Okay, plus 3H2O 5. Basically dia matematik tau. You kena banyak kali calculate. Sampailah elemen untuk alumina, hidrogen, nitrogen and oksigen belah kanan sama dengan belah kiri. Okay. Okay, so this is the answer lah. Okay, 10 alumina. On the right side, 10 here. Okay, and we have alumina here also 10, right? 5 times Al2 here. So we have 10 alumina. Okay, and for hydrogen we have 6, right? On the right side 6, and on the left side also 6. 3 times 2. Okay, and how about the nitrogen? We have 4 times here we have 5 times 6 equals to 30, right? And then nitrogen here 15 times 2 equals to 30. Okay, and then how about the oxygen? How many numbers of elements of oxygen on the right side? How many numbers of oxygen on the right side? 6 times 3, we have 18, right? 18 of oxygen. Okay, and how about the number of oxygen on the left side? 3 times 5 equals to 15 plus 3, right? So we have 18 oxygen on the right side, left side. Okay, right side and left side is same. Okay, so you will get the balance equation, okay, by using this equation lah. Okay, can you understand for the third one, the third equation? Okay, basically it's all about mathematics. Okay, you need to balance all the element on the right side and also on the left side. Okay, how about the number 4? Question 4, CH4 plus O2 equals to CO plus H2. This one easy, right? Number 4. On the right side, we have how many carbon? 1. 1, right? And on the left side, we have 1, right? Okay, so okay for carbon. And how about hydrogen? On the right side, we have 4. And on the right side, on the left side, we have 2. So how to make the hydrogen on the left side becomes 4? We need to time with 2, right? Okay, so 2 hydrogen here. Okay, 2 hydrogen here equals to 4, and this one also is 4. How about the oxygen? Oxygen here is 2, right? And this one is 1. So we have to make the oxygen becomes 2. So we times with 2. Okay. And here we have 2 carbon. Okay. So here we have to put 2 carbon to make the equation is balanced. And then how about the hydrogen? Hydrogen here we have 4 times 2 is 8. Okay, but here we have 4, right? So we have to make the equation equals for hydrogen becomes 8. So we times with what? We times with 4. Okay. So we can we get the equation is balanced lah on the left and right side. Okay. And for the last question, okay, calcium oxide plus HCl equals to CaCl2 plus H2O. Okay. Okay, now we see here the number of calcium is 1. And here is 1. Okay, good. And for oxygen, here we have 1, and this one also we have 1, right? So it's balanced for oxygen. And how about the hydrogen? Hydrogen here we have 1, and here we have 2. So we have to make the number of hydrogen is balanced. So we need to times with 2, right? Okay, so we have 2 hydrogen here and 2 hydrogen here. And how about the Cl, chlorine? Chlorine here we have 2, right? 2 times 1. And here we have also 2. So the equation is balanced, right? Okay, can you understand this exercise?
Yes.
Yeah, good. Easy or not? Easy, right?
Which
Okay,
practice
so
easy.
very easy, right? So it's all about mathematics lah. If you good in mathematics, so should be no problem for you for this. But you need to understand the principle first lah. Okay, next we have stoichiometric ratio. Okay. Okay, so what is stoichiometric ratio? Just now we have stoichiometric coefficient, right? Okay. Just now we have stoichiometric. Eh, sorry. Okay, just now we have stoichiometric equation, and then we have stoichiometric coefficient. Stoichiometric coefficient is the number written in front of the atoms or molecules. And now we have stoichiometric ratio. Okay, stoichiometric ratio is the ratio of two molecular species that participate in a reaction. Okay, is the ratio of their stoichiometric coefficient in the balanced reaction equation. Okay, so stoichiometric ratio ni kita buat bila dah equation kita dah balance. Bila dah balance baru kita boleh dapat ratio stoichiometric. Okay. And it is used as a conversion factor to calculate the amount of a particular reactant or product. Okay, digunakan sebagai conversion factor lah untuk calculate amount reactant dan juga product. Okay, next we have the second example. Okay, still the same equation, right? Okay, from this equation, okay, what is the stoichiometric ratio of SO3 generated to the oxygen consumed? Okay, first we have to make sure that the equation is balanced or not. Is it balanced? Before we do stoichiometric ratio, we need to make sure the equation is balanced. Okay,
Balance.
the equation is balanced, right? We have two sulfur here. Okay, we have two sulfur here, and here also 2, and oxygen we have 4 plus 2 equals to 6, and here also we have oxygen equals to 2 times 3 equals to 6, right? So the equation is balanced. Okay. Okay, so what is the ratio of SO3 over oxygen O2 consume? O2 consume the oxygen in the reactant side, right? SO3 is the in product side. Okay. Okay, so what is the ratio of SO3 over O2 consume?
One by one.
SO3, here we have, what is the, basically stoichiometric ratio is the ratio of coefficient. Okay, ratio of coefficient of one molecular over the other chemical species lah. Okay, so for the first question, we have SO3 over O2. We have, what is the coefficient for SO3?
2.
2. Okay, and what is the coefficient for O2?
2 also.
O2 here. Coefficient for SO3 here, we have 2, right?
O2 1.
Okay, and coefficient for O2 here, we have 1, right? So the ratio stoichiometric of SO3 over O2 equals to 2 over
2 over 1.
2 over 1, right? So equals to 2. 2 je pun. Kan? Senang tak? Okay, and then the second one, what is the stoichiometric coefficient of SO3 generated to the SO2 consumed? So the coefficient for SO3 we know. What is the coefficient for SO3?
2.
2. And what is the coefficient for SO2?
2 also.
2 also. Okay, so 2 over
1/1 lah.
2/2 equals to 1, right? So one just now we have 2 over oxygen 1 equals to 2. Okay, how about the last one? How many pound moles of oxygen reacts to form 200 pound moles of SO3?
100 pound.
How to solve this equation? We know that two molecules of SO2 will react with one molecule of O2 and produce 2 molecules of SO3, right? Okay, so now we want to produce 200 pound moles of SO3. Okay, so how
Bagi
many?
2.
Bagi 1, 2. Apa yang bagi 2? So we have
200 pound tu.
200 SO3, right? Divide by coefficient for SO3 equals to 2, right? So we get 100, right? And then, so now we want to calculate how many pound moles of oxygen. We know that the coefficient here is 1, right? So here is 1 oxygen. So we want to calculate how many pound moles of oxygen react with SO2 to produce 200 pound moles of SO3. So we have how to calculate 100 times what? Times 1, right? Equals to 100 pound moles of O2. Okay. So the answer is 100. Okay. Can you understand? Can you understand the last question,
Yes.
the last example here? Okay, just mathematics. It's all about mathematics. Okay.
Nak tanya untuk soalan 1.
Ada soalan nak tanya. Apa? Boleh kuat sikit tak? Tak dengar.
Nak tanya soalan 1.
Ah,
Ratio bukan kena tulis tu ke macam 2/1 tu yang ada macam ni lah kat mesej 2.
cakap mesej. Sama je lah. Dua ni sebuah satu equals to 2 lah. Maksudnya 2 okay lah ni. Boleh accepted juga. Okay, ataupun you tulis 2 pun accepted. Okay. Ada lagi soalan lain nak tanya setakat ni? Yang the third one ni faham tak? Faham kan? Just a simple mathematics, right? Okay, right. Okay, next slide. Okay. Have a limiting reactant and excess reactant. And also we have fractional excess. Okay, so what is limiting reactant? We know that stoichiometric for this example, okay, we have a reactant on the right side and we have product on the left side, right? For this example, what is the chemicals that involved in the reactants? As a reactant, we have SO2 and also O2, right? Oxygen. And the product is SO3. Okay. Okay, so here we have on the reactant side, we have limiting reactant and also excess reactant. Okay, so limiting reactants can be defined as the reactant that would run out first if a reaction proceeded to completion. Okay, or in other words, the reactant that will be finished first. Okay, if the reaction is proceed until complete. Okay, and next we have excess reactant. Excess reactant is the other reactants that is not limiting reactant. Maksudnya reactant yang excess lah. Maksud, okay. Limiting reactants adalah reactant pengehat ataupun bahan tindak balas yang akan habis dulu. Sebelum reaction tu complete, dia dah habis dulu. Okay. And the excess reactant ni adalah bahan tindak balas yang excess, berlebihan. Maksudnya satu reaktan tu, satu chemical tu dah habis, tapi ada reaktan lagi satu tu yang tak habis lagi, dia excess. That is excess reactant and limiting reactant. Okay. And then we have fractional excess. Okay. Fractional excess is the ratio of the excess to the stoichiometric requirement. Okay. Maksudnya pecahan yang reactant yang excess tu. Okay. Ratio of the excess to the stoichiometric requirement. Okay, so this is the equation. The fractional excess of reactant A, for example, equals to moles of feed minus moles of stoichiometric over moles of stoichiometric. Okay. Okay, so this one is stoichiometric requirement of A. And, this one is stoichiometric requirement of A, and this one is the stoichiometric the number of mole in feed. Okay, so excess, we want to calculate the fractional excess. Okay, moles of feed minus moles of stoichiometry over moles of stoichiometry of the reactant, of the excess reactant. Okay. Okay, now we have example 3. Okay, we have this equation. Okay, this stoichiometric chemical equation. Okay, so we have here, we have acetylene, hydrogen react with hydrogen to produce C2H6. Okay, so from the question, we have 20 kmols per hour of acetylene and 50 kmols per hour of hydrogen fed to the reactor. Find the limiting reactant. So we have two reactants here. Okay, so we want to decide which one is the limiting reactant. Is it acetylene C2H2 or H2 is the limiting reactant? Okay, so now we have two choice to determine which one is the limiting reactant. Okay. Okay, first of all, what we have to do first? We have to make sure the equation is balanced, right? Okay, so can you check this equation is balanced or not? Here we have 2 carbon and here we have 2 carbon. Okay, here we have 2 hydrogen plus 4 hydrogen equals to 6 hydrogen, right? And on the product side, we also have 6 hydrogen, right? So we can say that the equation is balanced, right? Okay, so now we have two choice to determine which one reactant is limiting. Okay, first, okay, from the stoichiometric equation, okay, we know that 1 kmol of C2H2 is needed to react with 2 kmol of H2, okay, to produce 1 kmol of C2H6, right? Okay, the first solution, we can use at 20 kmols of C2H2 as a starting point. Okay, so we know that this one reacts with 2H2, produce 1, right? Kmol of C2H6. And now we have 20 kmols of C2H2. So we need to times with, scale up to 20. Okay, we times with 20, so we get 20 kmols hour. Okay, so from here, 20 kmols per hour, we react with how many kmols of H2? 20 times 2, right? Equals to 40. Okay, and produce 20 kmols of C2H2, right? But from the question, we have 20 kmols per hour of C2H2, and it is given that the excess And the question given to us that the information on H2 is 50 kmols per hour. So 50 kmols per hour is less than 40 or more than 40?
More.
More, right? So so we can say that the H2 is excess, right? Okay, because 50 is more than 40. It should be 40 kmols only reacts with 20, but the hydrogen fed to the reactant is 50. So we can say that the hydrogen is excess. Okay. And the second one, we can choose 50 kmols per hour of H2 as a starting point. Okay. So 50 we times hydrogen to 50. Okay, so 50 scale up to 50. So we have 50 H2. 50 H2 divide by 2, we have 20, right? 50 kmols per hour divide by 2, we have 50 over 2 equals to 25, right? Okay, so 25 here times is 1 kmol, 25 kmol of C2H2, right? Okay, so but the number of moles of C2H2 that fed into the reactor is 20. Okay, but for 50 kmols of H2 needed 25 kmols of C2H2, okay, to react. But the moles of C2H2 fed to the reactor is only 20. So 20 is less than 25 or more than 25. That's that, right? So we can say that it is not enough lah. Okay, tak cukup. The number of mole of C2H2 is not enough to react with 50 kmols. So we can say that C2H2 is the limiting reactant. Okay?
Faham.
Faham? Alright. How about the others? Okay, hope you can follow until now. Okay, and next. Okay, try to solve this example. Okay, we have 20, still the same example. 20 kmols of acetylene and 50 kmols of hydrogen fed to a reactor. Okay, find the percentage of excess. Okay, we know that the excess is what? Hydrogen, right? Hydrogen in excess is the excess reactant and C2H2 is the limiting reactant, right? So, we want to calculate the fraction excess of H2. Okay, equals to the number of molecules hydrogen fed to the reactor minus with the number of hydrogen that required from the stoichiometry over the number of molecule hydrogen required by stoichiometry. Okay. Okay, so we have 50 kmols minus 40 kmols over 40 kmols per hour. Okay. And then time hundreds, we can get 25%. So we can say that 25% of hydrogen excess, okay, in excess of H2 in excess. Okay. Right. Okay, next. Okay, okay, try to solve this exercise. Okay, I give you 10 minutes. You do first. Okay, and we will discuss after this. Try to solve first. Okay, I give you 10 minutes to solve this this exercise. Okay, so here we have C4H8 plus reacts with O2 to produce CO2 plus H2O. Okay. Okay, is it the stoichiometric equation is balanced? The equation is balanced or not?
Tak.
Tak balance. Apa yang tak balance? You calculate dulu. You solve dulu. You buat dulu exercise ni. Okay, lagi 5 minit kita discuss balik jawapan. Okay, just bagi saya jawapan sekejap lagi. Sambil kita discuss. Okay. Have you finished? Have you finished done this exercise? Okay, so the first question is the stoichiometric equation is balanced. Balance or not?
No, tak balance.
Tak balance. Okay, macam ni you tahu tak balance? How do you know the
Tu
equation is not balanced?
C dia tu banyak sangat kat belah kiri.
Bilangan karbon, hidrogen, oksigen tak sama kan? Kiri dan kanan kan? Okay, here we have how many carbon? We have 4, right?
4.
4. Okay, sini ada berapa carbon?
1.
1, alright. Hidrogen kat sini ada berapa?
8.
8. Sini ada?
2.
2. Tak sama dah kan? 8, 2. Oksigen sini ada? 1 kan? Oksigen sini pun ada? 2. Okay. So how to make the equation is balanced? Okay. Sini kita ada carbon 4. Sini ada 1. So macam nak balancekan carbon?
Letak 4 dekat
Letak 4
carbon
dekat?
dioxide.
Alright. Okay, so kita letak 4 kat sini. Okay, so carbon dah balance. And then how about hydrogen? Balance tak hydrogen?
Letak 4 dekat H2O.
Sini ada 8. Sini ada 2. So nak jadikan 8 kena darab dengan?
4 darab 2.
4. Kan? Betul dah 4. 4 darab 2 kan? Dapat 8 kan? So hidrogen sini dah cukup 8. 4 kali 2, 8. Sini pun 8. Okay, and then oksigen. Oksigen kiri dan kanan cukup tak?
Tak.
Tak.
Ah.
Okay. Kat mana? Sini ada 2. Sini ada berapa oksigen?
12.
4 kali 1, 4. Tambah 4 kali 2, 8 kan? 8 tambah 4?
12.
12. Okey, sini ada 2. Macam mana nak jadikan 12?
Letak 6.
Darab dengan 6. Okey, so question kita dah balance ke belum?
Dah.
Dah, alright. Okay, so our equation dah balance. Okay, so what is the stoichiometric coefficient of CO2?
4.
CO2 mana CO2? Okay, 4. So the answer is 4. And then what is the stoichiometric ratio? Stoichiometric ratio of H2O to O2. Ratio, dia nak ratio. Ratio is the perbandingan koefisien kan?
2/3.
H2O berapa? H2O. Koefisien untuk H2O is
4.
4. 4. Koefisien untuk oksigen?
6.
Oksigen 6 kan? 4 nisbah 6. Right? Macam sama juga 2
3.
nisbah 3. Okay. Ataupun 4/6 pun boleh juga. Okay. Okay, and then how many polymers of oxygen reacts to form 400 polymers of CO2? Kita nak produce 400 of CO2. So, berapa banyak oksigen yang kita perlukan? Macam mana nak buat? Berapa banyak polymers of O2 diperlukan untuk bertindak balas untuk menghasilkan 400 polymers of CO2? Kita nak produce 400 polymers of CO2. So, berapa banyak polymers
600.
of O2 diperlukan? Macam mana nak kira? Berapa jawapan dia, oksigen? You get the answer?
600 patutnya.
600. Macam mana boleh dapat 600?
Kejap.
400 bagi 4. Right? Sebab, kenapa bagi 4? Sebab coefficient untuk CO2 is 4, right? So, 400 divided by 4 equals to 100. Right? And then, nak kira berapa banyak polymers oxygen reacts. So, berapa coefficient? Berapa number coefficient untuk oksigen?
6.
6 kan? Okay, so 6 darab dengan 100. Okay, equals to 600. Okay, 600 polymers of O2. Okay, semua dapat jawapan sama tak? 600.
Dapat.
Ada yang tak dapat? Okay, semua dapat 600 polymers of O2. Okay, very good. Okay, the last question. Okay. 100 polymers per minute of C4H8 fed into a reactor and 50% only reacts. Okay, 50% daripada 100 polymers C4H8 ni only 50% reacts. Okay, at what rate is water formed? Ni KBKK sikit kan. Okay, so how to solve this problems?
Cari stoichiometry untuk C4H8 dengan H2O.
Dengan water, right? Okay, so kita tahu yang masuk C4H8 yang masuk dalam reaktor adalah 100 polymers, right? 100 polymers. Tapi only 50% reacts. Maksudnya berapa yang react? Daripada 100 polymers ni, berapa yang react? Separuh yang react kan? So, yang react separuh daripada 50 over 100 times 100, right? Lepas tu 50, right? Do you agree with me?
Yes.
Agree tak? Polymers per min of C4H8 X. Yang bertindak balas hanyalah 50. Okay, 50 polymers of C4H8. Okay. So now we want to calculate how much the water form. Macam mana nak kira?
Tuhan darab 4.
Okay, so polymers 50 coefficient untuk C4H8 berapa? 1, right?
1.
1. Okay. 50 bagi 1. Lepas tu 50 kan? Okay, and then berapa coefficient untuk water produce?
4.
4. Alright. So sekarang ni kita nak kira berapa pound moles water yang produce. So 4 darab dengan 50. Okay. Lepas tu 200 moles per mean of H2O produce. Okay. Semua dapat jawapan sama tak? Ada yang dapat jawapan lain daripada 200 tak? Yang lain dapat jawapan 200 ke dapat jawapan lain? Dapat jawapan sama ke jawapan lain ni? Faham tak? Untuk soalan 5 ni faham tak? Sama. Semua dapat sama?
Sama dapat, faham.
Kan? Faham Make sure you faham. Okay. Okay, sebab kita punya final exam pun akan keluar satu soalan daripada topik ni lah. Make sure you faham lah. Okay. Alright. Okay, next we have fractional conversion pula. Okay, so what is fractional conversion of a reactant? Okay, so fractional conversion F equals to moles reacted over moles fat. Okay. Okay, to calculate the percentage conversion equals to F time 100. Okay, so moles reacted maksudnya moles yang bertindak balas over moles yang masuk. And then we have here extent of fraction. Extent of fraction ni apa pula kan? Okay, so the extent of fraction is the amount in moles or molar flow rate of a species converted in a fraction divided by the species stoichiometric coefficient. Yang ni you need to faham betul-betul lah. Okay. Okay, so extent of fraction formula dia adalah moles reacted over stoichiometric coefficient. Okay, equals to moles in minus moles out over stoichiometric coefficient. Okay. Okay, so Ni equals to feed quantity plus coefficient times the extent of fraction. Okay. Kat sini baru kita guna yang coefficient yang kalau sebelah reactant tu negatif kan, yang tadi tu yang saya beritahu tadi. Yang untuk reactants coefficient akan jadi negatif. Okay, and for product coefficient dia akan jadi positif. Mana tadi? Ni. The value of V coefficient for each reactant is negative. Okay. And the value of V for each product is positive. Okay, kena ingat. Kalau reactant negatif. Kalau product is coefficient dia adalah positif. Okay, yang tu kita akan guna untuk kira extent of fraction. Okay, so extent of fraction moles reacted over stoichiometric coefficient. Okay. Right. Okay. Okay, so we have this is C2H2 plus 2H2 equals to C2H6. Okay, we have this equation. Okay, first of all, you need to make sure the equation is balanced or not, right? Before you do anything, you calculate the ratio stoichiometric, you need to make sure the equation stoichiometric equation is balanced or not. Okay. And after the equation is balanced, you can proceed to calculate everything. Okay, so from this equation, is it balanced or not balanced? Is it balanced?
Balance.
Balance, right? We have 2 carbon here, and here we have 2 carbon on the product, and hydrogen, we have 2 hydrogen on the reactant, plus 2 times 2 equals to 4, 4 plus 2 equals to 6, right? 6 hydrogen here, and here also we have 6 hydrogen. Okay, so we can say that the equation is balanced. Okay, the stoichiometric equation is balanced. Okay, now we have 20 kmols per hour of acetylene and 50 kmols per hour of hydrogen are fed to a reactor. Okay, so if the reactions proceed to completion, okay, if the reaction is complete, how much of the excess reactant will be left? Okay, and how much C2H2 will be formed? And what is the extent of reaction? Okay. Okay, from this chemical equation, just now we have done, right? So which one is the limiting reactant just now? Do you still remember? The limiting reactant is H2 or C2H2?
C2H2.
C2H2, limiting reactant, right? Okay, and then how about the excess reactant? The excess reactant is
H2.
H2 lah kan. Salah satu akan limiting reactant dan yang reactant yang lagi satu tu dia akan automatically excess lah. Okay, so we know that the excess reactant is H2, right? Okay, so we want and the other one just now I say to you that for reactants, the coefficient for reactants must be negative, right? Okay, so this one we have 1, right? The coefficient here is 1, so we have negative 1. Okay, negative 1 for C2H2, and this one also is reactant or product? This one reactant or product? Reactant, right? So reactant we need to put negative. Okay, put negative for the coefficient. Okay, so we have negative 2 here for H2, and C2H6 is the product, right? Okay, so for coefficient for product should be positive. Okay, so positive 1. Okay. Okay, so first you need to draw a table like this, and then you write the stoichiometric coefficient for each reactant and also for each product. Okay, so we have here negative 1, negative 2, and also positive 1. Okay, so how to calculate the extent of reaction? We use this equation. Okay, the extent of N C2H2. Okay, we replace the stoichiometric equation negative 1 here. So VC2H2 is negative 1, right? So we put here negative 1 plus negative 1, so should be negative 1 lah. Okay, and for H2, okay, plus coefficient H2, here we have negative 2, right? So it will become negative 2 extent of reaction. Okay, negative 2 times the extent of reaction. Okay, and for the product here, we have positive 1, right? Okay, so plus VC, the coefficient for C2H2 is positive 1. Okay, so positive 1 extent of reaction. Okay. Okay, so how to solve this example? Okay, from the previous example, we know that the limiting reactant is C2H2, right? Okay, first we need to identify which one is the limiting reactant. Okay, so from the previous example, we know that C2H2 is the limiting reactant, right? How to calculate the limiting reactant? Just like this, the previous example lah kan. Okay, so the reaction will be occurred until this reactant finish to be consumed. Maksudnya, daripada equation tadi, C2H2 tu adalah limiting reactant. Maksudnya reactant C2H2 tu dia akan habis dulu sebelum reaction complete, dia dah habis dulu. That is the limiting reactant. Okay. Okay. From the previous slide, the extent of reaction equation of C2H2 is okay. Okay, from the previous slide, C2H2, you get this equation, right? And C2H2 equals to NC2H2O minus 1 extent of reaction times extent of reaction. So find the limiting reactant. Okay, from this equation we want to find the limiting reactant here. Okay, untuk you must to bear in your mind that to calculate the extent of reaction, you kena kira daripada limiting reactant tu. Okay, the basic is from your limiting reactant. Okay. Okay. Okay, so daripada equation ni 0 kmol C2H2 equals to 20 kmols per hour C2H2 minus 1 times Okay, kenapa sini dapat kosong? Ada siapa-siapa boleh tahu tak kenapa sini dapat kosong? C2H2. Why this one is C2 0? Okay, so and C2H2 ni adalah bilangan mol yang selepas tindak balas habis. Selepas habis tindak balas, so C2H2 kan dia limiting reactant kan? Betul tak? Limiting reactant maksudnya dia akan habis dulu kan? Maksudnya bila dia habis dulu, selepas tindak balas tu habis, maksudnya berapa mol yang tinggal?
Kosong lah, tak ada, dia habis.
Kosong lah kan, sebab tu kita dapat kosong kat sini. Okay, bilangan mol yang habis equals to bilangan mol yang fed into the reactor. Bilangan mol C2H2 yang masuk reactor minus coefficient value times extent of reaction. Right. This one faham kan kenapa dapat negatif 1 kan? Sebab daripada coefficient kat sini. For reactant must be negative. Okay. Okay, so moles yang masuk adalah 20, right? Betul tak 20? 20 kmols of acetylene fed to a reactor. That's why 20 lah. Sini 20. Okay, 20 minus 1 times extent of reaction. Sekarang ni kita nak kira extent of reaction. Okay, so bila kita dah masuk value, so kita akan dapat the extent of reaction equals to 20, right? The extent of reaction equals to 20 kmols per hour. Okay. Okay, so kita tahu hydrogen adalah excess reactant, right? So by using the extent of reaction equation of H2 and the value of extent of reaction obtained, okay, then kita boleh kira berapa moles yang left after the reaction. Okay. Okay, so basically ni untuk extent of reaction ni, okay, dia punya basic formula dia adalah okay, NC2H2 ni adalah bilangan moles yang tinggal selepas habis reaction. Okay, you kena faham macam tu. Ni adalah bilangan moles yang tinggal selepas habis reaction. Selepas habis tindak balas sama dengan bilangan moles yang yang masuk plus bilangan moles plus dengan coefficient untuk chemical species ni times dengan extent of reaction. Itulah you kena faham. Okay. And untuk H2 pula sama juga. Bilangan moles yang tinggal selepas bilangan moles yang tinggal lah selepas habis reaction sama dengan bilangan moles yang masuk untuk chemicals tu plus coefficient value untuk chemicals tu times dengan extent of reaction. Sama juga dengan yang ni pun. Okay. Bilangan moles yang tinggal maksudnya dia produce lah kan, sebab ni produk. Bilangan moles yang terhasil, bilangan moles yang terhasil equals to bilangan moles yang fed to the reactor should be kosong lah kan, sebab dia adalah produk kan, plus the coefficient times extent of reaction. Okay. Okay, and then tadi kita dah kira, kita dah identify limiting reactant tu adalah C2H2. Okay, and then kita dah masukkan nilai bilangan mol yang terhasil selepas tindak balas adalah kosong sama dengan bilangan mol yang masuk adalah 20 minus 1 times extent of reaction. So you dapat extent of reaction is 20 kmols per hour. Okay, you kena ingat dalam kepala you extent of reaction ni dia mesti basic dia adalah kita kira daripada limiting reactant. Okay, so bila kita dah dapat extent of reaction value ni, bila kita dah dapat extent of reaction value ni, kita guna untuk excess reactant lah, kita kira untuk hydrogen pula. Okay, so kita guna formula yang sama. Okay, and H2 ni adalah apa tadi? Bilangan mol yang terhasil selepas tindak balas kan. Okay, sama dengan bilangan moles yang masuk reaktor untuk hydrogen tadi adalah 50, right? 50 kmols minus 2 ni kita dah dapat daripada coefficient untuk hydrogen tadi, right? Ni 2 minus 2. Okay, minus 2 times extent of reaction. Extent of reaction ni yang kita dapat tadi lah, 20 kmols per hour. Okay, so kita dapat bilangan moles yang tinggal selepas tindak balas adalah NH2 equals to 50 minus 40 kmols per hour. So we will get 10 kmols per hour. Okay, which is the amount of excess reactant left at the end of the reaction. Okay, so kita dapat jumlah excess reactant of hydrogen selepas tindak balas adalah 10. Okay, 10 kmols per hour. Okay, and then to get the amount of C2H2 pula untuk produk. Produk dia adalah C2H2 kan? Betul tak? Ni adalah produk dia, C2H2, which one we know that the coefficient is 1, right? For product is positive 1. Okay, positive 1. Okay. So, kita nak kira berapa kmols yang terhasil selepas tindak balas untuk C2H2. C2H2 ni adalah produk yang terhasil. Okay, equals to berapa value of C2H2 fed to the reactor? Ada tak? Ada ke tak ada?
Tak ada.
Tak ada kan? Sebab apa tak ada? Sebab dia adalah produk kan? Dia bukan reactant. Kalau reactant adalah berapa yang masuk kan? Sebab dia produk jadi zero lah kan? Zero lah sebab mana ada, dia adalah produk kan? Produk tak ada yang masuk lah kan? Dia yang terhasil sebab tu dia zero. Okay, so 0 C2H2 plus 1 extent of reaction. Kenapa 1 kat sini? Kenapa 1 kat sini plus 1? Saya nak tahu you all faham ke tak? Kenapa plus 1?
Sebab dia produk.
Sebab dia produk. Okay, sebab dia produk ni. Kalau produk dia mesti plus. Kalau reactant negatif. Okay, plus 1 coefficient untuk produk tu. Okay. So plus 1 times of extent of fraction. Extent of fraction ni kita guna yang tadi lah, yang kita dapat tadi 20 kmols daripada limiting reactant tu kan. Okay, so just substitute the value for extent of fraction 20. Okay, so hence we will get the number of moles produced after the reaction equals to 0 plus 20, right? 0 plus 20 kmols per hour. Okay, so we will get 20 kmols per hour of C2H2 produced after the reaction. Okay. Okay, setakat ni ada apa-apa soalan tak nak tanya? Tak faham kat mana? Ada yang tak faham tak? So untuk extent of fraction you kena ingat formula ni lah. Basic formula. Okay. The basic formula is this one. Okay, berapa moles yang tinggal equals to berapa moles masuk plus coefficient times dengan extent of fraction. Okay, and then you daripada equation ni you kena identify dulu which one is the limiting reactant. So limiting reactant ni maksudnya dia akan habis dulu dan selepas tindak balas value yang kosong lah kan, dia habis lah, tak ada kmol yang tertinggal, so dia adalah kosong. Okay, sebab dia habis digunakan limiting reactant tu. Okay. Yes. Okay. Ada apa-apa soalan tak nak tanya untuk ni excess of reactant ni? Daripada awal sampai sekarang. Ada yang tak faham tak? Any question from you? Ada tak faham? Okay, so kita buat revision balik boleh? Kita ada masa sejam lagi kan? Okay, ada yang tak faham ke?
Faham.
Ada soalan nak tanya? Dari ni untuk part 1, okay? Lepas raya kita akan belajar untuk part 2 lah. Okay. So untuk this course you need to untuk this part you need to identify the chemical reaction stoichiometry, okay, in terms of the limiting and excess reactant. Okay, you need to know what is limiting and excess reactant, fractional conversion, extent of fraction, yield and selectivity ni on the next lecture. Okay. Okay lah. Okay, I nak tanya soalan, you jawab kat chat boleh? Boleh ke tak?
Boleh.
Sebab kita ada sejam lagi ni nak habiskan. Okay. Okay, so what is limiting reactant? Okay, tu dia jawapan kat chat ni. What is limiting reactant? Limiting reactant tu apa? Lagi ramai ni. Semua ada 111. Ni baru berapa orang jawab ni? 1, 2, 3, 4. What is limiting reactant? Yang lain-lain? Ni baru 10 orang ke ni? Yang lain-lain what is limiting reactant? Yes, very good. Lagi yang lain-lain. What is limiting reactant? Reactant yang habis dulu, right? Okay, ramai yang cakap limiting reactant is reactant yang habis dulu, limitkan reaction, reactant that finish first, reactant that totally consumed by the reaction. Okay. Reactant that does not have excess, reactant yang dah habis dulu, reactant run out first if reaction complete. Ada lagi. Reactant that get consumed first. Okay. Okay, so the second question is after the reaction finish, how much the limiting reactant left? Zero. So, okay. Yes, good. Zero, right? Okay, what else question? Okay, what is the excess reactant? We have limiting reactant, we have excess reactant. What is excess reactant? What is excess reactant? Reactant yang berlebihan lah kan? That have excess. Reactant yang excess. Okay, good. Okay, next question. When we have a chemical equation, okay, what is the first step that we need to do first before we proceed with all the calculation? Balance the equation. Okay, balance. Right, we need to balance the equation first, right? Okay, how to make the equation balance? Basic question. Macam mana kita nak make sure the equation is balanced? Adding coefficient. Lagi? Kita kena make sure the number of element on the right side and the number of element on the left side is same, right? You kena letak perkali coefficient sampai bilangan elemen chemical species on the right and left side is same. Okay? Jangan careless. Okay, jangan careless kat situ. Okay? Kalau you punya coefficient salah, so you punya calculation nanti pun akan totally salah. Right? So that's why very important to determine to make sure the equation is balanced. Okay. Okay, next is apa lagi nak tanya you? Nak make sure you faham kan? Sekejap, coefficient. Okay. What is stoichiometry ratio? What is the stoichiometric ratio? Siapa boleh jawab soalan pagi ni? Maksudnya you faham lah. Nisbah berkali ratio of coefficient, right? For two elements, right? Lagi ada jawapan lain lagi tak? What is the ratio stoichiometry? Ratio stoichiometry. So ratio of coefficient of two chemical elements, right? Okay. And then what is the equation for fractional excess? What is the equation for fractional excess? Fractional excess. Fractional excess is the moles of chemical feed minus moles of stoichiometry required by stoichiometry divide by moles of required by stoichiometry. Okay, that is the fractional excess. Okay, and then what else? What is the calculation for fractional excess? Fractional excess. Fractional excess, we have fractional excess. Okay, fractional excess equals to moles of chemical feeds minus moles of required by stoichiometry divide by moles of required by stoichiometry. Okay, that is fractional excess. Okay, and then what else? Okay. Okay, yang ni kalau you boleh jawab ni memang you betul-betul faham lah. Okay. Okay, untuk kira extent of fraction, right? Extent of fraction ni kita kira berdasarkan apa? What is the basic calculation untuk kira extent of fraction? Apa benda pertama yang kita kena buat sebelum kita nak kira extent of fraction? Yes, balance the equation. Betul. Okay, kita kena make sure equation tu balance atau tidak dulu kan. Kalau tak balance, kita kena balancekan dulu. Okay. Okay, lepas kita balance, lepas equation tu dah balance, kita dah balancekan equation tu, apa kita kena buat untuk kira extent of fraction? We need to know the limiting reactant. Okay, extent of fraction you kena ingat. You kena identify first the limiting reactants. Okay. So you punya calculation untuk extent of ratio tu you akan calculate based on the limiting reactant tu. Kalau you salah pilih limiting reactant, so akan salah lah semua kan. Betul tak? Sebab tu you kena faham betul-betul, you kena identify betul-betul which one is the limiting reactant. Okay. Okay, so untuk reactant, untuk kira limiting reactant ni, coefficient untuk reactants negatif or positif? Negatif. Ada yang cakap positif tak? Ada yang kata positif ke semua negatif? Alright. Okay, so negatif semua faham kan kenapa negatif kan? Negatif. Kalau reactance, koefisien dia kena negatif. Okay, kalau for product, koefisien untuk produk untuk kira extent of reaction should be positif. Alright, positif. Ada yang kata negatif, semua positif. Okay. So, positif. Okay. Okay, so basically untuk kira extent of reaction ni, sebenarnya apa yang kita nak tahu daripada extent of reaction ni? Kenapa kita kira extent of reaction ni? Soalan cepu mas. Kenapa kita kira extent of reaction? Sebab kita nak dapatkan apa? Apa tujuan kira extent of reaction? Kalau tak boleh jawab soalan ni, tak boleh balik lagi. Yes, jumlah produk yang akan terhasil. Bagus, Nafizuddin. Right, good. Okay, so kita kira extent of reaction tu sebab kita nak kira selepas reaction tu, okay, selepas habis reaction berapa produk yang terhasil dan juga apa lagi? Berapa produk yang akan terhasil untuk reactant? Untuk reactant, untuk apa pula kita kira extent of reaction tu? Ni siapa boleh jawab? Yes, berapa banyak yang akan digunakan? Sikit lagi nak tepat dah, sikit lagi. CP dah. Untuk reactant kenapa kita kira extent of reaction? Sebab kita nak tahu access reactant that we use. Lagi. Saya nak tengok siapa yang jawab betul. Lagi. Amount of reactant reacted. Ya, tapi CP dah tu. Saya nak jawapan yang tepat. Lagi ada jawapan lain lagi tak? Kalau untuk produk kita kira limiting rate, untuk produk tu kita kira extent of reaction tu sebab kita nak tengok berapa banyak produk yang terhasil kan selepas tindak balas kan. Untuk reactant kita nak tengok apa? Saya nak tengok siapa jawab tepat ni. Ya, betul tapi kurang tepat lagi. CP dah tu. Siapa boleh jawab tepat? Sikit lagi. Yang lain-lain lagi mana ni? Semua ada 100 orang ni. 113. Lagi kurang tepat. CP dah tu tapi saya nak satu jawapan yang tepat lagi. Saya nak tengok siapa yang boleh jawab tepat ni. Lagi yang lain apa lagi jawapan? Calculate the rate of reaction. Yes, kurang tepat. Sikit lagi. Lagi. Not of needed. CP dah tu. Sikit lagi. Lagi. Kita nak habiskan masa dengan kita tengok siapa boleh bagi jawapan yang tepat. Kalau dia boleh jawab ni dia memang betul-betul dah master untuk lecture hari ni. Any other answer? Boston. Calculate the rate of fraction. Yang lain-lain mana lagi? Baguslah kelas ni. Ni baru berapa orang jawab ni? 1, 2, 3, 4, 5, 12. Ni baru 20 orang ni. Lagi 80 orang mana lagi? 80 jawapan lagi sepatutnya ada kat sini. 80 orang tak jawab lagi ni. Reacted from the product. Lagi. Coefficient lagi. Kurang tepat. Return react. Yes, return react. Kenapa kita nak kira extent of reaction tu? Untuk return. Yes, more needed. Yes. Concentration. Kurang tepat. Time for reaction use. Ni lagi advance ni. Okay, lagi. 1 mole of reactants has converted into product. Lagi. Kurang tepat. Measure. Lagi. Okay. Lagi. Soalan cepu mas ni. Kenapa kita guna limiter reactant untuk reactant? Excess amount of the reaction occur. Yes. Lagi. Kurang tepat. Lagi. Ni lagi 50 orang ni. Tak jawab lagi ni. Fikir. Yes. Lagi kurang tepat. Maaf, limiting reactant. Yes. Yes, lagi. Determine the, ya, kurang tepat. Sikit lagi. To find the initial concentration. No. Not sure. Okay, so I bagi lagi satu clue. Okay, untuk produk, okay, untuk limited extent of reactant, get consume first. Ya, kurang tepat. Sikit lagi. Okay, untuk produk, kita guna extent of fraction tu untuk kira berapa produk yang terhasil selepas tindak balas, right? Okay, untuk return, kita nak kira berapa produk yang can be formed. Yes, this one untuk product, right? To determine the amount of a product that can be formed. This one for product. For return, to determine what? Okay. Amount of excess produce. Sikit lagi dah nak CP-CP dah tu. Return use lah. CP-CP lagi tu. Sikit lagi. Excess return lagi. Lagi. Amount of return kurang tepat. To end reaction, no, return use. Return needed. Return needed to complete. Kurang tepat. How many return that we use? Sikit lagi tu dah nak tepat sikit lagi. Kita nak tengok siapa yang boleh jawab dengan tepat ni. Exact amount of return. Kurang tepat. Siapa boleh jawab tepat ni memang you betul-betul faham lah. Lagi. Coefficient, lagi. Amount of produce. Lagi. Kurang tepat. Satu jawapan yang tepat. Sikit lagi. Balance of return. Yes, Muhammad Akmal. Okay, I dah dapat dah. Okay, balance of return after reaction. Maksudnya, untuk return ni kita guna limiting rate of limited rate. Kita guna apa? Extent of reaction ni untuk kira apa? Untuk determine berapa banyak return yang terhasil. Return yang tinggal selepas tindak balas. Tu fungsi dia. Kita nak tengok untuk return selepas reaction habis, berapa return yang tinggal lah. Produce after berapa banyak return yang tertinggal selepas yang tak habis digunakan selepas tindak balas. Tu jawapan dia. Okay, so untuk produk extent of reaction tu kita nak kira, nak determine berapa banyak produk yang terhasil. Okay, untuk return ni selepas habis tindak balas kita nak kira, kita guna extent of reaction ni untuk kira berapa produk yang masih berbaki selepas habis tindak balas. Okay, yang limited return tu confirm lah 0 kan. Untuk excess return tu berapa banyak produk yang terhasil, berapa banyak return yang baki yang tertinggal lah, yang tak habis digunakan tu. Berapa banyak yang tertinggal return yang baki daripada return yang tertinggal tu selepas habis tindak balas. Okay, faham tak semua? Faham? Okay, tahniah. Siapa tadi nama? Siapa tadi? Muhammad Akmal. Okay, balance of return after reaction. Okay, good. Very good. Okay, that's mean you faham lah lecture untuk hari ni kan. Okay, so do you have any question? Kita ada masa banyak lagi ni. Tapi I dah cover semua dah untuk week ni untuk 2 kelas hari ni dan esok. Yang lain faham tak? Faham. Make sure you all faham Kalau tak faham, bagi tahu kat mana yang tak faham. Okay. Semua happy nak raya esok. Esok raya. Siapa rasa esok raya? Nanti saya upload dalam e-learning. You rasa esok raya ke Sabtu raya? Siapa umum? Tak tahu pun. Semua dah beli baju raya ke? Okay, sekejap Saya nak Okay, so I will give you assignment. Okay, this is will be our first assignment lah. Right. Okay, so this is our first assignment. Okay, we have 2 questions here. Okay. First, you need to determine which one is limiting return and which one is the excess return. Okay, based on the most given to you. Okay, and the second one, you are given the equation and you need to determine which one is limiting, which one is calculate the percentage excess. Okay. Okay, so this will be your assignment. Okay. Okay, the assignment should be done in group. Do you have a group? You dah ada group untuk assignment tak? No. Oh, you tak ada group untuk assignment lagi Okay. Okay, I nak tanya, you sebelum ni kelas dengan Dr. Arthur kan? Right. So, you ada group assignment dengan Dr. Arthur tak? Kita tu ada bagi assignment. Oh, belum ada assignment. Okay. So you can form a group of three lah. You group assignment, form a group of 3 person. Okay. So okay. So this is a group assignment. Okay. You can form please form a group of 3 ke 4. 3 person in a group. Okay. And then please submit this assignment on 26. Assignment on 26, 30. Okay, submit. Due date 30 for due date. Okay. Please form a group of 3 person. Okay, in a group, and then please submit the assignment before 30 April. Is it okay? Okay. We have empat. Okay lah. 4 person. A group of 4. Group of 4. Kita perlu ikut kelas tak? Apa maksud ni? Tak faham. Okay, so form a group of 4 person in a group. Okay. And the due date is 30 April. Okay. Oh, ikut program. Oh, sekarang you ada berapa program dalam ni? Ikut program. Okay. Group of 4 ni ikut program. So tak bercampur program lah. Okay. Ikut program. Okay. So nanti I upload in the e-learning. And wait, okay, so copy. Wait, we still have 40 minutes. Okay. So, wait. Okay, so this is wait, not finished yet. Wait, this one. Alright. So, new student password. Yes. Okay, now please scan this barcode for your attendance. Okay. So we have 2 barcodes here for 2 class, for today class and tomorrow class. So you need to scan 2 barcode. Wait. Okay. Yes. Eh, eh. Okay, I give you 5 minutes to scan this barcode. For the first barcode, okay, 3 more minutes. Ada yang tak scan lagi ke? Okay, you need to scan 2 barcode. Okay, this one is the first barcode. Hmm. Okay, ada yang tak scan lagi? Semua dah scan dah? The first barcode. Hmm. Okay, so I think we can move to the second barcode. Okay. Okay. Okay, now you can scan for the second barcode for tomorrow class actually. Okay, for Friday 1 hour lecture. Okay. Okay, okay, siapa yang semua dah scan? Ada yang tak scan lagi ke? Alright. Okay, make sure all of you have scanned the barcode, 2 barcode, okay? Ada yang tak scan lagi tak? Ke semua dah scan dah? Okay, hopefully all of you have scanned the barcode lah. Okay. Okay, so I think that's all for today, I think. Okay, if there will be no any question, I think we can stop here lah. Okay. Okay, so thank you so much for coming today. Okay. Okay, so with that, I end our lecture. Okay. Okay, so selamat Hari Raya Aidilfitri. Okay, have a nice holiday. Okay. Okay, thank you so much. Alright. Okay. Thank you. See you after 2 weeks, right? Okay. Thank you everyone. Selamat Hari Raya.
Thank you, Doctor.
Okay. Yes.
Thank you, everyone. Selamat Hari Raya Aidilfitri to all. Hi, Madam Shaswani.
Hi. Oh, Doctor.
No worry, no, I'm just checking if the attendance are okay. Right, I look at the e-learning. Seems like some of them are not haven't checked in yet, but it's okay. Maybe they just never pay attention in class. Don't worry too much. Thank you so much.
Okay.
I think nice job today. So after this, I will not join. Next week, they will be normal class or they will be done online. Yeah, Doctor.
Yes.
Actually, the
We
week,
will
the
have
week after.
physical class, right?
Yeah, the week after that. So,
Yeah.
all right, no worry. You can download the QR code from the e-learning next time for them to scan. All right.
All right. Okay.
Okay,
Thank you so much.
Take care, everyone.
Okay.
Selamat Hari Raya juga, Doktor.
Thank you, Doktor. Selamat Raya.
Selamat Raya.